Okay, this is a PowerPoint for the answers to the questions I set you at the end of the Core Prac 16 PowerPoint on respirometry. I set you 2 exam questions. Here's the first one. So we've got a diagram here. We can see that we've got a little screw clip at the top there that's kind of open and closing to let air in and out. We've got a boiling tube, we've got our small organisms, we've got the gauze, we've got the potassium hydroxide, and we've got that manometer right there. Okay, so you can see the manometer here with our graduated scale, so we can take measurements, little organisms there respiring, some potassium hydroxide. Remember that potassium hydroxide is going to absorb the CO2 as they respire, so you get that change in the volume of the air molecules, gas molecules if you like, and it's going to cause this manometer to move. So the question is, with the screw clip open, what's going to happen? Okay, so with the screw clip open, that's going to be letting air in. So air's going to be coming in and out. So as these respire, it's going to make no difference to sort of the pressure or the volume in here. So it's going to be here. Screw clip is open so it doesn't move. Oh. Sorry about that. So it doesn't move. It's going to be on there. With the screw clip closed, well, with the screw clip closed, as these little organisms respire, they're going to be taking oxygen out of that little tube. The CO2 is going to be resorbed with potassium hydroxide, so we're going to find our level is going to move up here. So it's going to be towards A. So it's going to be down there. And then it's potassium hydroxide replaced with water, and the screw clip is closed. So this is now water. So any CO2 that is released is not going to be being absorbed, it's going to be staying in there. So they're going to be taking oxygen out and just replacing it. So there's going to be no movement. So it's going to be, it does not move. Okay, so that's the answer to that one. And there's the mark scheme there, you can see. Lovely. And it's 3 marks, so it's 1 for each row that you get right. Second question was this one. So an investigation was carried out to test the effect of temperature on the rate of respiration in germinating seed. Diagram shows a respirometer that was used to carry out the investigation. And we can see we've got a tube here with nothing in it. I've got a germinating piece here. We've got some potassium hydroxide there. We've got a graduated scale. And the important thing is the effect of temperature here. The effect of temperature on the rate of respiration. Okay. So, devised an investigation using this respirometer to obtain valid data to show the effect of temperature on the rate. So the idea is valid data. How are you going to make sure your data is valid? Remember, it's valid if you control all your variables. The effect of temperature, so you're going to be changing your temperature somehow, aren't you? Probably using a water bath, I would have thought. And then the rate of respiration, so how are you going to work out your rate? What measurements have you got to take? You better tell the examiner that. And also, I think you probably ought to be doing something about this big old empty tube sitting here. What's going to go in here? Why? Now, it's an asterisk-based question, but apologies to you. I think I cut the asterisk off, so sorry about that. But it is an asterisk-based question, so like normal, it would be level 1, level 2, level 3. The kind of definitions or descriptors don't change, but they're on the next page. You can read them again. And remember, you can include things that are relevant that aren't on that little sort of bullet point mark scheme, and they will include it, and it will be counted. Remember, they're going to read your answer as a whole, read what you've written. It's not kind of looking for 6 marking points. It's reading it as a whole, and coming up is level 1, level 2, level 3. So let's look at the mark scheme for that. So, some way of setting a constant temperature. So I think you're probably going to be using a water bath there. You could use you could do it with a you could just say using a water bath. Range of temperatures. Remember, 5 is always good. But remember, you've got living organisms, so you're not going to put them really. I wouldn't have thought above sort of 40. But you could use quite cold. But yeah, you're not going to, because they're living organisms. It's not ethical. You're going to want some sort of syringe. You can be resetting your apparatus. We're going to keep taking it apart all the time. So controlling a variable, use the same mass of seeds. Okay. Repeating measurements. So remember, the more reliable it is. Sorry, let me rephrase that. For reliable data, you do repeats. Modifying the left-hand tube. So if I can just go back, it's this tube here. You've got to do something about it. It's your control tube. And remember, it's a control tube, so everything is kept the same apart from the thing you're investigating. So you're going to want to make sure some glass beads are in there. You're going to make sure that it's the same mass as the seeds that you're investigating. You're going to want the same volume of potassium hydroxide in there. Okay. So yeah, they were the answers. Thanks.